Cells are a bit like prison cells, which is where each of these individuals are placed. Everyone has an individual cell. The individuals in the central part of the cells are called sites. The positions where these edges meet, which is the outside of the cells, are called vertices. Therefore, this point here is a vertex. So in addition to the cell, vertex and sites, we also have the keyword edges. All of these are quite counterintuitive, but make sure you understand what each of these mean. The first thing we're going to do is we are going to draw a Voronoi diagram for question B. Now, whenever you're constructing a Voronoi diagram for 3 points, you have to do the following. First of all, you need to find the midpoint of the 3 lines. So we've got A, B and C. So we'll do AB, BC and AC. Once you've found the midpoint, you need to find the gradient of each of the lines. So we're going to find the gradient of AB, BC and AC. Once you've got the midpoint and gradients together, you can find the perpendicular bisectors. So we need to find the perpendicular bisectors of each of the lines going through the midpoints. Again, you need to do this 3 times for AB, BC and AC. Now let's talk about what this actually means in practice. This is our completed Voronoi diagram. And here on the left-hand side are working out for the diagram. The first thing that was calculated then were the midpoints. 1, 2, 3. This was done by using the midpoint formula, which is given to you in the exam. Please ask me if you're not sure of the midpoint formula. Once they have the sum on the numerator, they simplify it to get a single point of midpoint for AB. So AB, which is the point joining A and B, we're going to say the midpoint is minus 1, which is going to be here. The next thing they're going to do is find the gradients, which is how steep the line is. So the gradients were found once, twice, and 3 times. This tells us how steep the line is. So the gradient of AB is minus 3/4. This means this blue line, I'm going to try and draw it straight and fail miserably. This has a negative gradient, and this means that for every 3 spaces it goes down, it goes across 4. The comparison or the change of y, this triangle means change of y over the change of x. Now, we have all 3 things we need for the midpoint and all 3 things for the gradients. We can combine this information together to find the perpendicular bisectors. Now, the perpendicular bisectors are the lines which cut the lines in half. So cut line AC in half, CB and AB, for example. Now, to calculate the perpendicular bisectors, there are several ways we can do this. I'm going to show you one way, which is a pictorial way. Let's have a look at the perpendicular bisector of AC. The first thing you need to do is have a look for the midpoint of AC. The midpoint is minus 4, 0, which is identified here. The second thing you need to do is then have a look at the gradient for AC. The gradient of AC is going to be minus 2. So the gradient of the perpendicular bisector is going to be the reciprocal of minus 2. We take minus 2, we flip it, and we change the sign. So the gradient of the new line for AC is going to be 1/2. Now, these represent the steps in the y and the x axes respectively. So this means for every 1 step to the right for y, we go 1 step up for y, we go 2 steps across for x. So 1 step up for y is going to be 2 steps across for x. Therefore, we have found 2 points on this line and we can create this as the perpendicular bisector. If you're not very happy with that particular method, what you could do is work out the equation of the line. The equation of the line is going to be y equals 1/2 x plus c. We then need to substitute in y and x using the midpoints. So we're going to substitute in -4, 0. So 0 equals 1/2 times -4, and then that's going to give us the value for c. So this is going to be -2, therefore c is equal to 2. So another way of working this out would be to suggest that the intercept of this line is going to be 2, and therefore one of the coordinates of this graph is going to be 0, 2. So rather than finding out this middle point, you can go straight to finding this point here if you're not sure of my description of this bit here. The final and third way of finding out the equation of this line would be to substitute 2 back into the equation. So we've got y equals 1/2 x plus 2, and then creating this as a graph on the y equals button on the calculator. So what we're going to do is we're going to go onto the y equals, we're going to press clear on a current value. We're going to type in this formula 1/2 x plus 2, or 0.5 x plus 2. And then what we're going to do is have a look at the table. The table shows us all the coordinates on that graph. So for example, you can find the coordinates -2, 1. You could find the coordinate 0, 2. Because when x is 0, y is 2. So recapping the 3 ways you can find the perpendicular bisector. The first thing you could do would be to use the gradient, which is 1/2, and apply that to the midpoint. So for this means for every 1 space up, we go 2 spaces to the right. The second step was to work out the y-intercept. We did this by substituting in the gradient into the formula, finding the value of c, and then understanding that it crosses the y-axis at 0, 2, and therefore one of the points it must go through is 0, 2. And then the third way we did this was to do the same step, but then substituting the c back into the equation, plotting it on the graph, and seeing from the table the different coordinates on this particular perpendicular bisector. What we need to do then is repeat the process a whole 3 times. We want to find 3 perpendicular bisectors. The line that splits A to C in half, the line that splits C to B in half, and the line that splits B to A in half. We are going to therefore be shown these following dotted lines and straight lines. The first thing I would start with would be to split two of the points in half for the perpendicular bisector. So the first line that we did this with was with line 1, L1. And then we're going to find the perpendicular bisector between A and B. The perpendicular bisector for A and B is going to be this line here, which we're going to call line 2. And then finally between C and B, let's call this line 3. Now the dotted lines are not part of the Voronoi diagram, but the straight lines are. So when you first draw these line 1s, line 2s and line 3s, which all represent the perpendicular bisectors, what you need to make sure you do is draw them fully dotted. And then once you start seeing the cells forming, you can decide where you're going to put the straight lines and where you're going to put the dotted lines. You can see that all 3 meet at this vertex here. And the key thing you need to think about is common sense. We're going to keep L2 as a dotted line for this part of the diagram because C is already in its own cell. It's the central part of its cell. It's equidistant between these 2 lines. Similarly, we don't need this part of dotted line 1, and we don't need this part of dotted line 3. You need to make sure the diagram looks symmetrical and that the cells and the sites have an equidistance from the edges. Please let me know if you're not sure about how to draw the straight lines and the dotted lines. Let's have a look at this question. This map shows the locations of Pablo's pizza stores in the city. When customers ring Pablo's Pizza, they are automatically transferred to their nearest store. The first thing that we want to do is construct a Voronoi diagram. So like the previous question, what you need to do is find the perpendicular bisectors for all 3 lines. Please pause the video and have a go at this question now. Hopefully you found out that the perpendicular bisectors will be as following. The first one we're going to calculate is the perpendicular bisector between A and B. This is going to be what line cuts AB in half. First of all, you can see that the line that cuts AB in half is going to be a negative gradient. However, it also crosses the y-axis at a positive intercept. This is a sketch, and in an exam you'd be expected to draw an exact drawing, which I'll show you how to do in a moment. Once you've calculated the equation, you should have something like the following. Then we can find the perpendicular bisector of AC. And then we can find the perpendicular bisector of BC. The first thing I'm going to do is find the midpoint of AB. That should have already been worked out, and I can tell you now that the midpoint is going to be half a square across from this x coordinate, so 4.5, and then 2.5 up, so it's going to be 4.5, 0.5, so it's going to be exactly in the middle here. Now, we want to find another coordinate on this particular graph. Now, this one's going to be a little bit trickier, but because it's got a format of y equals something x plus 1.4, it means it crosses at 1.4. So this is going to be approximately here. So as long as you identify these 2 key points and you draw the line, you're going to get the marks in the exam. Let's do the same this time, but for line AC. So line AC is going to have a midpoint of the distance, which is halfway between A and C, or the point which is halfway between A and C. So adding the x's together, that's going to be 1, so it's going to be 0.5 for the x, and then for the y, it's going to be 3 plus minus 6 divided by 2, which is going to be minus 1.5. So the midpoint between lines A to C is going to be this green dot. This means we can join these 2 points together with a straight line as well. Again, make sure in the exam you are clear with what part is significant in the diagram. The final thing we need to do is draw this line, minus 2x minus 4. So let's have a look at the midpoint between B and C. That's going to be minus 4 plus 4. It's going to be 0 for the x coordinate, and for the y coordinate it's going to be minus 4. So 0 minus 4. And now we need to use the table of values on the calculator to work out another coordinate it goes through, or just substitute in a random value. That's another way of doing it again. So I've given you about 4 ways of doing this. So let's have a look. If we replace x with 1, what's y going to be? So when you replace x with 1, y is going to be -6. So when x is 1, y is going to be 1, 2, 3, 4, 5, 6. So our final line is going to join up these 2 points as well. So our Voronoi diagram is looking better. However, some of them is going to be dotted lines. So for example, because this line cuts this cell right in the middle, we don't need this. So we're going to extend it to here. And we would keep this line in if we wanted to as a dotted line. And that would be our completed Voronoi diagram. Now, I'd like you to have a go at question B and pause the video now. Welcome back. Hopefully you had a go at question B. The answers to question B were as follows. Store A for part 1, store A again, and then finally we are going to have store C. Question C then is really straightforward. She is equidistant. Now the vertices represent the equidistant point from all 3 sites. So there's only one vertex, so the answer is going to be obvious. The answer is going to be -3, 2. And then working out how far, you need to use the distance formula. The distance formula works in the following way. x1 minus x2 squared plus y1 minus y2 squared. And because all of the sites C, B and A are all equidistant from the vertex, it doesn't matter what you substitute in. So we're going to substitute in obviously the vertex, because we want to work out the distance from the vertex to C, the vertex to B, the vertex to A. But it doesn't matter whether we substitute in A, B or C. For simplicity, I'm going to substitute in A because they have got positive nice numbers. I'm going to write out A, 5, 3, and this is going to be our vertex. Let's call this x1, y1. Therefore, this one must be x2, y2. And substituting in the relevant values, we get the following. 5 minus 3, which is going to give us 8. 8 squared is going to give us 64. 3 minus 2 is going to give us 1. 1 squared is 1, so we need to find the square root of 65. Excellent work here. The square root of 65 is simply going to be 8.06 meters or kilometers even to 2 dp. I hope this video has helped you, and stay tuned for the next video for more complex problems again. Well done for your perseverance.